Hi everyone, welcome to another video of midterm 1 for Math 100. So this time we are gonna solve this midterm from 2023, October 6th, Friday. And on that day, there were multiple midterms. So you will see this date several times, but each of them has different questions. Maybe the questions are very similar to each other, but the numbers or some variables would be slightly different. So you have a 45 minutes. They had 45 minutes and they were not allowed to use calculator or cell phone like any other exams. So the first problem they are asking to evaluate A and B. So the function f is continuous and differentiable. And there is a hint that they said start with differentiability. Just mentioning something, in this type of question, sometimes they don't say continuous at all. Just mentioning differentiable, a function can be differentiable if it's continuous. So continuity is kind of prerequisite for differentiability. So they don't have to mention continuity. So let's begin. To figure out if it's differentiable, we need to make sure that its derivative is continuous. So let's find out what its derivative is. So f prime of x is equal to, it's made of two pieces. For x is less than or equal to b, the function is x, so the derivative of that would be just 1. And for x is greater than b, the function is square root of x minus a. Square root of x minus a. Let's take the derivative of this one. So first thing that we can do here is we can rewrite that as x minus a to the power of half and use the power rule. So the derivative of that would be 1 over 2 times x minus a to the power of 1 over 2 minus 1 is 1 over 2 times x minus a to the power of negative half, which we can write it as 1 over 2 times 1 over x minus a to the power of half. And power of half means square root, so it's basically 1 over 2 square root of x minus a. So I just write it here as a derivative for the second piece. 2 times x minus a. Okay, let me get rid of this stuff here. Okay, now we have a derivative of the function f. Now we want to make sure it's differentiable, so we need to make sure that its derivative is continuous. So this one doesn't have a problem, this one doesn't have a problem. The problem is when we are connecting these two pieces with each other, which basically is at point B. So what we need to do is we check the limit of the f prime of x when x approaches to b from left to be same as the limit of f prime of x as x approaches to b from right. So if these two are same, it means the function is continuous. The f prime is continuous, which makes f differentiable. So what is the left limit? Because we are taking the limit as x approaches to b from the left side, so we are dealing with numbers less than b, which basically are x is less than or equal to b. So instead of that one, I can write limit of basically 1 as x approaches b negative, which there is no variable here, so it's basically 1. So this is for this part. I'm approaching x is approaching to b from the right side, which means x's are greater than b, like this case. So I can write the limit of 1 over 2 root x minus a as x approaches to b from the right side. And we simply plug in b into x. So we get 1 over 2 minus a. This is kind of coming from this part. To make it differentiable, we need to make sure the derivative function is continuous. So the left and right limits are same. So basically 1 is equal to 1 over 2 root b minus a. We can rearrange it. Let's multiply both sides by this denominator. So we get 2 root b minus a is equal to 1. Or we can divide both sides by 2. So root b minus a equal to 1 over 2. Squaring both sides, b minus a should be 1 over 2 squared, which is 1 over 4. This is the first thing that we know. The b minus a should be 1 over 4. Let me just write it in a different way. B minus a is equal to... Okay, so if b minus a is equal to 1 over 4, we know the limit of the derivative from left and right are same. There is another requirement for differentiability, the function to be continuous, the function itself to be continuous. So we need to make sure this function that we are given here is also continuous. So let's check the continuity of that function. How to check that one? So to check the continuity of a function, we take the limit of that function, the piecewise function, and again, the issue will happen when x is equal to b. Because this one is continuous, this one is continuous. The problem is where they are meeting each other. Are they kind of connected or they are not? So we'll take the limit of f of x as x approaches to b from left. Just pay attention. Here it was f prime. Here it's just f. Because here the first part we were checking the continuity of a derivative. Here we are checking the continuity of the function itself. So when f of x, x approaches to b from the left side, we are basically dealing with the first expression because x's are slightly less than b. So it would be a limit of x as x approaches b from left is equal to just b. We simply plug that. Let's do it again from the right side. So limit of x approaches to b from the right side equal to limit of, okay, x approaches to b from the right side, x's are slightly greater than b, so we are dealing with the second expression. So it should be root x minus a as x approaches to b from positive side, which this one is equal to square b minus a. Again, we want to make sure that the function f is continuous, so we need to make sure that the b is equal to root. Okay, so this is the second equation that we have. Second equation, first equation. So we need to find a and b, so both of these equations are satisfied. So in this one, let's see what we can do. Oh, okay. Here b minus a, we know it's a quarter, so let's just plug that here. So I just write the first equation, b minus a is equal to 1 over 4. So we can combine these two and figure out b is equal to a square root of 1 over 4, which is 1 over 2. So b is equal to 1 over 2. What is a? We can use this equation, for example. So we know, take this equation here. 1 over 2 minus a is equal to 1 over 4. So 1 over 2, let's move negative a to the other side, and 1 over 4 to this side. 1 over 2 minus 1 over 4 is equal to a. So basically a is equal to 4. So basically with these, with the having a and b equal to 1 over 4 and 1 over 2 respectively, we make sure that this function is continuous, and because its derivative is also continuous, it will be differentiable as well. Okay, let's move to the second question. This question addresses the use of asymptotics to help with graphing the function. The first part they're asking, what is the derivative of f of x? Okay, let's take the derivative of that function. So f of x is equal to e to the x over 1 plus e to the x. And they are asking for f prime of x. Prime of x is equal to, okay, we have a fraction, so quotient rule should be the first thing that comes to mind. What is quotient rule? Quotient rule says take the derivative of the derivative of top, which is derivative of e to the x, which is e to the x, times bottom without changing the bottom as is, minus the derivative of the denominator. Okay, the derivative of 1 is 0, plus the derivative of e to the x is e to the x, times top, which is e to the x, over the denominator squared, the whole thing is squared. So this would be the f prime of x. So let's simplify it a little bit so it looks better. So let's distribute as much as we can. So we can multiply e to the x into the bracket, e to the x plus e to the x times e to the x, it would be e to the x plus x because they have the same base, or basically e to the 2x minus 0 times e to the x is 0, and e to the x times e to the x is e to the 2x over 1 plus e to the x squared. It's better to keep the denominator as is without kind of expanding that. So what we will get is cancel these two, and we get e to the x over 1 plus x. This is the derivative of the function f. Okay, so the second part they are asking, for what values of x is f prime of x positive? For what values of x is f prime of x is negative? Let's see. So let's rewrite the f prime of x. F prime of x, based on what we got, is e to the x over 1 plus e to the x squared. Okay, if a function wants to be we have a function which is a numerator divided by a denominator. So if this fraction wants to be positive or negative, we need to focus on the sign of each different section of that. So let's figure out, let's investigate the numerator and see if it's positive or negative, or for what x values it would be positive, for what x values it would be negative. E to the x, if you remember the graph of e to the x, the graph of e to the x very quickly looks like this. And what we need to know is it's always above the x-axis. So basically, it is always positive. E to the x is kind of always positive. Okay, how about the denominator? We have e to the x, which is always positive, plus a number 1, which is more even positive, and you are even squaring that, so definitely it's positive. The denominator is also positive. Okay, doesn't matter for what x value. Any x value you put there, the numerator would be positive, the denominator would be positive, so the whole fraction would be positive. So basically, for all x values, f prime of x would be positive. And it is never negative, basically. So the answer for the first part would be all real numbers, and second part would be kind of none. It is always positive. And positive derivative, you know that means the function is increasing. So for all the x values, it is positive, means the function is always increasing. Okay, let's go to part C. In part C, we are asked, what is the linear approximation to f of x near x equal to 0? Linear approximation, those are just fancy words for what? equation of tangent line. Basically, linear approximation is equation of tangent line. So how do we find the equation of tangent line? We can use the slope point form. But what is a slope point form? Let me just write the equation for that. Y minus y1 is equal to the slope times x minus x1. And x1 and y1 are the coordinate, these two are the coordinate of one point of the line. What is m? M is the slope. No matter what method you are gonna use, you need the slope for the line. What is a slope? A slope is the derivative. So slope is coming from f prime of x, which is e to the x over 1 plus the x squared. And we are writing that we are evaluating the linear approximation near x equal to 0. Basically, they could say near x equal to 0, or they could say at x equal to 0. They mean the same thing. So we plug in 0 here. We need the slope at 0. F prime of 0 is e to the 0 over 1 plus e to the 0 squared, which is any number to the power of 0, except 0 is 1. And the denominator is 1 plus 1 is 2. 2 squared would be 4. Okay, 1 over 4, this would be the derivative at 0, or basically slope. Okay, we know the slope of the tangent line. How about x1 and y1? 1 point of that. So we are dealing with, or we are writing the tangent line at x equal to 0. So let's use the same point. And don't forget that, for example, whatever function it looks like, for example, something like this, at any point, tangent line and the function are sharing 1 point with each other. So you can evaluate the y coordinate of that point by plugging the x coordinate into the line equation or the function or the curve equation. They are giving you the same y value. Let me just erase this stuff. So what I do, I plug in 0 into the function f of x. Basically, I evaluate f of 0. What is f of 0? It is e to the 0 over 1 plus e to the 0. Let me write f of x again here. F of x is the original function, is e to the x over 1 plus. This is basically the equation that they gave us. Okay, we have this, and now we can simply evaluate that. E to the 0 is 1, e to the 0 plus 1 is 2. Basically, 1 point, the point that we are writing the tangent line equation at, is 0, comma, and 1 over 2. Okay, now we have the slope of a tangent line. We have a coordinate of 1 point on the line. So we can write the equation of tangent line is y minus y1. So this would be the y1, 1 over 2, is equal to m, the slope that we found, 1/4, times x minus x1, which is this 0. So overall, y minus half is equal 1/4 of x, or y is equal to 1/4 of x. Let's move this to the other side, which makes it plus half. So this is basically the linear approximation of the function at x equal to 0. Let's go to the part D. What is the asymptotic behavior of f of x for x large and positive, for x large and negative? So asymptotic behavior is very similar to kind of taking limit, but here you are not taking limits. Just make sure that there's a tiny difference there. In asymptotic behavior, you are basically ignoring, you are neglecting the terms that are irrelevant. Let me just write the function here again. What is f of x? F of x is e to the x over 1 plus e. And let's analyze each of these two separately. For x large, like, I don't know, 1,000, 10,000, or 10 billion, just infinitely large, and it's positive 10 billion, something like that. And x large and negative is like 10 billion, just negative 10 billion, just negative side. Okay, when x is very, very large, very, very large and positive, what happens? What is dominating on top? Okay, on top we only have e to the x, so that's the dominating part. So e to the x is dominating on top. How about the denominator? Okay, you have e to the x, which is a huge number for positive numbers, plus 1. So that plus 1 is basically nothing. It is irrelevant. So you can ignore that one and say, okay, it's like this function. It behaves like this function. So let's simplify that, and it's just 1. The asymptotic behavior of this function for large x's is just like 1, just flat 1. How about for large x numbers, but negative? Let's see that. And so let me just write it for large positive x. And I just write it with blue, that for large negative x. Okay, on top, what do we have? E to the very, very negative number, which is almost 0, basically. And in the denominator, we have just 1. Basically just 0. It behaves like a function 0. So nothing is left there. So, and these functions are just basically flat lines. So what we know, on the very right, it's just flat 1, and on the very left, it's just flat 0. So, and now they are saying that use this information that we found so far to sketch the graph. Okay, what we know? We know we are dealing with a function that for large positive x's, it's just 1. Because it's a number that is basically horizontal asymptote at positive infinity. Let's just have it here, if 1. And we know when x is very, very huge positive, the function should get closer and closer to this value. And when x is very, very negative, it should be closer and closer to 0, to this number. What else we know? We know the function is increasing. The function keeps going up, it's increasing. And also we know around 0, near 0, the approximation of the function, or the linear approximation of the function, looks like this. A quarter x plus half. Let's just sketch this one as well. A quarter of x plus half. So a quarter of x is just a straight line. That's just a line with a slope of quarter. And you have plus half, which means just shift it a little bit up, half a unit, which basically makes this point, the x-coordinate, the y-intercept of that, equal to half. So around 0, the function behaves like this. And you know, when it's very big number, the function gets closer and closer to this, and a very negative number, the function gets closer and closer to this. Why I don't go below that? Because I know the function should always be increasing. The function doesn't go down at any point. It's always increasing. So what happens? I'm dealing with a function like this. From almost 0, it becomes increasing. And it follows this line a little bit around here. And then it turns to these values. What they want to see, I mean, the actual function would be more like this. I have it a little bit in a more dramatic way here. The actual function would look like this. So basically what you need to show in this graph is First, you understand that the function is always increasing, and it goes and gets closer and closer to 1 on this side and closer to 0 to this side, and around 0 it's kind of tracking this line. Kind of tracking. It's not very necessary that exactly matches that, just having the same behavior at that. Perfect. Let's move on to next question and the last question of this midterm. In this question, we are asked that we are told that there are two distinct straight lines that passes through the point 1 and -3, and those lines are tangent to the curve y equal to x squared. And now we are asked find the equation of those two lines. So there is a curve. Let's just sketch it very small sketch here. We have x squared, which is something like this, and there is a point 1 and -3. So 1 and negative, just very rough, very kind of rough animation. Okay, so there are two tangent lines to this curve which they pass through this point. So maybe something like that's a really, maybe something like that, or maybe something like this. I mean, you got the idea. It's tangent to that curve and it's passing through the point. Let me just sketch one of them. Just sketch something like this. This is a line and I want to find this line. How to find it? I mean, we are basically finding the equation of a tangent line. And you remember, to find the equation of tangent line, you need to know where that line is kind of touching the curve, at what x coordinate is touching the curve. We don't know it here, but we know the tangent line is supposed to pass through this point. How can we use it? Let's begin with what we know. We know how to find the equation of tangent line if we have the x coordinate. So let's just name it. For example, we know it's touching the curve at this point. So let's just give it a name. This point has a coordinate like a and b. The coordinate of that point is a and b. We don't know what they are right now. But, sorry. But we know we can say something about b actually. What is that? Because the point A and B is on the curve, the y coordinate, which is b, should be, let me just, what is the curve? The curve is y is equal to x squared. So we know the y coordinate should be basically the x coordinate, which is a squared. So we know that. We know the b should be a squared. That's really helpful. I mean, we know at least one of them with respect to the other one. So basically, let me just keep it a and b here. Basically, this point is a and a squared. Okay. Now, what we are trying to do is finding the equation of tangent line which passes through or touching the curve at the point a comma a squared. Okay, let's find that. What's the first step? To find the equation of tangent line, we need to find slope of a tangent line. And what is the slope? We know the slope is the derivative of the function. So the function is y is equal to x squared. So the derivative of that, or y prime, is equal to 2x. So power rule, we know that. But what is the slope at that point? Okay, what is the point? The point is 1 at 1. At a, my bad. At a. So we want to know what is y prime at a. So we plug in a for x. So it is 2a y prime of x. So this is 2a. Now we have the slope. What is this? This is the slope of tangent line at x equal to a. Now you have the slope at that point, and you also have the point, which is a and a squared, a comma a squared. So we can write the slope point 4, which is y minus y1, the y coordinate of the point, which is a squared, is equal to the slope, which is 2a times x minus x coordinate of the point, which is a. What we found is the equation, not the slope, it's the equation of tangent line. Basically, whatever a value you plug there, you will see this is the equation of tangent line. But we are not looking for all of the equation of tangent lines. We are looking for the ones that pass through these points. How it would be different? I mean, so because the point 1 comma negative 3 is on the line, it basically means it will satisfy the line equation. We are saying this is the line equation. Y is equal. Let me just simplify the line equation first. So we have y minus a squared is equal to, let's distribute these into the bracket. So we get 2ax minus 2a times a, which is 2a squared. And let's move these to the other side. So it's y is equal to 2ax minus 2a squared plus a squared, which if you add them, it becomes just minus a squared. It was minus 2a squared plus a squared, so it is a squared now. So this is the tangent line equation. If you say the point, for example, 1 and 2 is on this line, it basically means you can, when you plug that into this equation, it satisfies the equation. So basically, because we know that the point 1 and negative 3 is on this line, is supposed to be on the line, what we do, we just plug the points coordinates into the line equation. So we say, okay, negative 3 is the y coordinate, and the x coordinate is 1. So negative 3 is equal to 2a times x, which is 1, minus a squared. So overall, we got negative 3 is equal to 2a minus a squared. If we find a, basically we are answering the question. We are saying if you find the equation of tangent line at that a value, at that x equal to a, whatever you found, it will pass through this point. So let's do that. Let's just move everything here to the other side. So make a quadratic equation. So let's move it to this side. So we have a squared minus 2a, and there's a negative 3 here, which is negative 3 is equal to 0. Actually, it's an easy function to be factored. So we have a minus 3 and a plus 1 equal to 0. So a has two values. Either a is equal to 3, or from this bracket, we know a is equal to negative 1. What is a? A is the x coordinate of the point that we set. So we are saying that, or we are claiming that at x equal to 3 and at x equal to negative 1, basically the tangent line at these two passes the point which is 1 and negative 3. So we are claiming this one. And now let's just write the equation of tangent line. So we already have the equation of tangent line very generally, but let's write it specifically for these two a values. So one of them would be y is equal to 2 times a. For example, let's plug this one, which is 2 times 3 times x minus a squared, which is 3 squared. And the other one is y is equal to 2 times negative 1 times x minus negative 1 squared. So the first one would be 6x minus 9, and the other one would be y is equal to minus x minus 1. These are the two tangent line to the curve which passes through the point. I hope everything we talked about in these three questions were making sense. If you had any question, feel free to reach out to me, and I try to answer as soon as I can. Have a good night.